Let us discuss refraction of light through a spherical lenses. All of you have seen a palmist using the magnifying glass to see the lines of the palm. The watchmakers use a magnifying glass to see tiny parts of the watch, and the people using spectacles for reading. Why do they use magnifying glass? What is a magnifying glass? The magnifying glass used in spectacles and that which the watchmaker and palmist use are actually spherical lenses. What is this lens? A lens is a piece of transparent glass bound by two spherical surfaces. Lenses are of two types: convex lens, concave lens. Let us first see what a convex lens is. A convex lens has two spherical surfaces bulging outwards. That is why it is called double convex lens. It is thicker at the middle and tapered at the edges. Convex lens converge light rays, so convex lenses are also called converging lenses. Now, let us see how the concave lens is different from convex lens. A concave lens is bounded by two spherical surfaces curved inwards. That is why it is called double concave lens. It is thicker at the edges than at the middle. Concave lenses diverge light, so concave lenses are also called diverging lenses. Now, let us understand the various terms related to convex lens and concave lens. Center of curvature. The center of curvature of a lens is defined as the center of the spherical surfaces from which the lens has been cut. Thus, there will two centers of curvature. The letters C1 and C2 represent them. Aperture. The effective diameter of the circular outline of a spherical lens is called its aperture. In the figure, the distance AB is the aperture of the lens. Principal axis. The line joining the centers of curvatures is known as the principal axis of the lens. Optical center. The intersection of the line joining the lens aperture and the principal axis is called the optic center of the lens. The optic center is denoted by O. Principal focus and focal length. Since a lens consists of two surfaces, there are thus first and second focus and first and second focal plane. When several rays of light parallel to principal axis are incident on a convex lens, they converge at a point on the principal axis. It is the principal focus of the convex lens. When several rays of light parallel to the principal axis are falling on a concave lens, they diverge from a point on the principal axis. This point on the principal axis is called the principal focus of the concave lens. Focal length. The distance between principal focus and optical center of the lens is the focal length. What happens when parallel rays of light are incident on a lens? Let us do an activity to understand this. The paper begins to burn, producing smoke. It may even catch fire after a while. Why does this happen? The light from the sun constitutes parallel rays of light. These rays were converged by the lens at the sharp bright spot formed on the paper. In fact, the bright spot you got on the paper is a real image of the sun. The concentration of the sunlight at a point generated heat. This caused the paper to burn.